When 1 gram of gasoline is combusted by a car engine, the amount of energy released is approximately 1.03 times 10 to the 4th calories. Express this unit in joules, horsepower hour, and kWh or kilowatt hours. So the givens in this problem are that there is 1.03 times 10 to the 4th calories. Units of calories is CAL typically, and that's the energy in the system. We're going to use E in this problem. Energy is one of those variables that gets a lot of different symbols, so I'm just picking E here. Now that was given in the problem statement, but there's some givens that are kind of hidden here, and that's that we're going to need to use unit conversions. And we need to know the conversion between calories and joules, and then some other conversions. We could know calories to horsepower hours or calories to kilowatt hours, but usually since joule is the SI unit, we go to joules as an intermediate conversion step, and then we'll go to the other units. So the conversion factors that I'm going to use are that 1 calorie is equal to 4.184 joules. And then I'm going to use the next two based on joules. 1 horsepower hour is equal to 2.685 times 10 to the 6 joules. And 1 kilowatt hour, or kWh, is equal to 3.6 times 10 to the 6 joules. So those are the givens that I'm going to use in this problem. Some of them were directly from the problem statement, others were constants essentially, and we need to find E in joules, E in horsepower hour, and E in kilowatt hours. So the solution method we're going to use is dimensional analysis. We're going to start with our original quantity of energy, 1.03 times 10 to the 4th calories. And then what we need to do is we need to use these conversion factors here as fractions to do the conversion. And so you could say 1 calorie per 4.184 joules, or alternatively you could say 4.184 joules per calorie. Doesn't matter which way you write that numerically, but to do the cancellation we need the calorie in the denominator of these fractions. So I'm going to write 4.184 joules per calorie, right? And what that shows us is that the calorie here and the calorie here cancel, and so we get 1.03 times 10 to the 4th times 4.184 joules. And so that's going to give us 43,095.2 joules. So if I convert 1.03 times 10 to the 4th calories into joules, I get an energy content of 43,095.2 joules. So now that I've got it in joules, I can use these two constants to do the conversion over to horsepower hour and kWh. We're going to use the same method, but instead of starting with it in calories, we're going to start in joules. 43,095.2 joules. And then I need to use this conversion right here. Joules is in the numerator here, so I want joules in the denominator of this fraction. 1 horsepower hour is equal to 2.685 times 10 to the 6 joules, or 1 horsepower hour per every 2.685 times 10 to the 6 joules. All right, so I do that, and we get a small number, 0.0161 horsepower hour is our energy converted over. And then we'll do one more example. Again, we're going to start with this amount of energy in joules here, 43,095.2 joules, and we're going to multiply by our last conversion constant, which is 3.6 times 10 to the 6 joules per kWh. So 1 kilowatt hour is 3.6 times 10 to the 6 joules. So again, joules is going to cancel here, and I do this, and I get 0.01197 kWh, should be a capital W, kilowatt hours. That's a little weird because normally we don't want to have that many decimals in a kilo term if we're using SI scientific notation, so we'd want to move that 3 places usually. And so if you get an answer like that, you're probably going to want to write it as 11.97 watt hours and remove the kilo. Remember, kilo is times 10 to the third, so I can just move that decimal point, right? And so that's going to be E there. So that's some basic energy unit conversions for you.